Thank you, Glenn. We're ready?
Yes.
Good morning. I want to revisit extended attributes. I've talked about extended attributes before. Every time I keep finding something new about them. Okay, let's get going. Basically, everything you wanted to know about extended attributes, I told Warpstock 2015. But since we all have a fantastic memory, I will repeat some of the stuff. As we know, OS2 and some other systems have extended attributes. Your standard attributes for files in OS2 and some other systems are the system, read-only, archive, and hidden bits. Extended attributes, however, are file system features that enables users to associate computer files with metadata, whatever that may be. Whereas regular attributes have a purpose specifically distributed by the file system, such as omissions, that is not true of extended attributes. In this case, a directory is also seen as a file with regards to extended attributes. The only problem is when you are handling extended attributes, the so-called approved method is to lock, well, not lock the file, but at least make sure you are opening it as share only so that nobody else can change it. You can't do that with a directory, so there's no way of protecting changing EAs on a directory. Great fun. The number of EAs per file is not limited. However, the total size of all EAs is limited to 64K on OS2. As we said when we were talking, I think it was 2 days ago, maybe on some system EAs are limited to other sizes, and that was a point to add to my other program, that you could limit it to prevent problems. Additional information about any file can sometimes be handy. Example, the icon of an executable is in extended attributes. So if you throw the icon away, all of a sudden you will not have a nice icon for that type of file. The long file name is another extended attribute, which may or may not be present. The long file name is what you normally see in the listing as title. Also, the long file name can have some nice, what do we call them, formatting characters. So for example, if you have on your desktop, excuse me while my stomach recovers, like when you have on your desktop a title on 2 lines, as part of that character string is a character return. There are also some other strange characters in there. Code page, as used to encode data, this will probably be more important on multilingual systems, I could imagine, because the code page and text sometimes has very large influence on each other. You can have a version number of a file. This I'm using in my local cloud program. And there are lots more. If you want to find anything about EAs, there's a number of programs. For example, EA Browse by Henk Kelder, which is part of WP Tools. In Search Plus, there's also a possibility to have a look at extended attributes. I have also made a long name check program some years back. EA Viewer by Kimes, that was part of FM2, is also extended attributes. So you do have a number of programs already which in fact look in some way or manipulate in some way extended attributes.
The DIR command can do it too.
Sorry?
The DIR command can look at them too.
Yeah.
A lot of people don't know that because the little thing is a flag.
The program I made, EA Master, is basically for well, it can do almost everything you think you would want to do with EAs. You can't see it very well, but basically it lists the file name and per file what EAs are present. If you select a particular extended attribute, you can see then the format of that extended attribute either as ASCII and hex or just hex. Any questions up to this moment, or we're still all sleeping? Okay. Some EAs are multiple value EAs. In other words, there's more than one thing in the EA name. There are sub-EAs, if you like, cascading. This is the ASOC table, association table, EA, and what you see is it is a multi-value, multi-type, which has in it multi-value, multi-types. And in fact, an ASOC table has 4 EAs in each EA. And you have maybe more, because as we know, you can have more associations to a file, for example. EA Master can list all of the EAs present in a file or directory. It makes no difference between it. It does, however, show, which you can't really see here well, a color change between a file or a directory, so you can identify what it is. You can copy EAs, you can cut and paste EAs, you can delete a specific EA, or you can delete all EAs of a specific type and or name if you wish. We know that I think it's GCC, was it, adds some EAs which for us we wonder why, because they don't seem to do anything for us or for the operating system itself. You can rename an EA, you can edit an existing EA, and you can create an EA. In other words, anything you normally can do with a file, you can now do with an EA. Complex EAs in this program are shown in a graphical information, which makes it a lot easier to understand because, well, we are graphically oriented people. You can search for a particular EA, either on name, type, or even contents, or combinations thereof. This allows you a very powerful way to find a particular item. If you find an item, you can also say, I want to delete it. So in fact, some of the dummy EAs produced by GCC, you can find them and delete all of them if you wish. It also has an undo function, limited to a certain amount because otherwise you just have to file too much information. So within reason, if you change anything, you can correct it. We said yesterday about if you change an EA, the file date changes. This program makes sure, even if you have changed the EA, the file dates are still as they were. This is very important, for example, if you're doing any backups and looking for things that have changed. You don't want, just because you looked at an EA or something, that the date has changed. The cut copy actions can be from the main menu directly. So EA actions, and then you select what you want to do. You can see you can do almost everything there, but you can also very simply, using the right-hand mouse button, a context menu, which is almost the same, and the difference is mainly that if you select that menu, you immediately will perform that action. You don't get the standard, are you sure? Do you really want to do it? Maybe, and you continue. As I said, they look almost the same, but there are some differences. Creating a single EA is fairly simple. You have to define the EA type. There are various EA types. In this case, which you can't probably see, we selected the ASCII type EA. You have to give it a name, which you can't see here either. But for example, this is an EA called MD5 checksum, which I use in some programs just to put a checksum behind the file, so you can cross-check that the file is still valid with the data when it was originally created. And this below is the format of that particular EA. This works fairly easy. You just put in the name, the type, and you start typing. You can do it in ASCII, hex, or binary, whichever is easiest depending on the type of EA. It will automatically count the number of characters and put that in the EA, unless you specifically say this EA should be, for example, 24 characters. You set 24 characters, and it will stop when it's 24, or if you haven't put 24, there's something wrong, he says. Of course, we have the handy, which you can't see, the discard button. So if you made a mistake and you said, no, this is all wrong, just throw away what you were doing. I said EA type, EA name, the critical flag. All EAs have a critical flag, but I've yet to find an EA where this has been set. This was one of the ideas, that some EAs are critical, but it seems never have to been implemented anywhere. But you can set it if you wish, and you can test on it. Size, as I said, can also be specified of the data you're about to enter. And as I said again, you can enter ASCII, hex, or binary. Creating a multi-value EA requires additional information. Because first of all, you've got to say is, how many sub-EAs are there in that EA? There are two multi-value EAs. One is MVMT, and the other one is MVMS, I think it is. But basically, the multi-value, multi-type, it says it, in this value you can have multiple types of EAs. So for example, here we start putting in an MVMT EA. We said there are going to be two EAs. This first EA, we now then have to fill in the data for that EA. That will open a new window. The number of type of each A you also have to specify, and this program will accept up to 7 levels of multiple EAs. I have not found anything more than 2 levels deep, but you know, there are always exceptions you will find if you don't allow it. That was basically EA Master up till the beginning of this year. I've added some extra tools which I found necessary when doing some stuff, and I thought, well, how do I find this out? One of them is to display the contents of a hold file. Now, what is a hold file? A hold file is a special file in a special format which contains EAs. These EAs can be produced this file can be produced containing these EAs either by the EA utility or by this program itself. The EA utility has the ability to strip EAs from a file or directory, put them into a file, and you can put that on a system that does not support EAs. And when you come back, you take those EAs and you join them back to the original file. This is what the command looked like: EA util, the name of the file, the hold file, and the options. And the options are remove or replace, overwrite, modify, join, and so on. So basically, the normal sort of things you can do. The hold file has a particular format. This is a standard format. I couldn't find it documented anywhere, so the first thing I did was I documented it in the help file belonging to this program, mainly because then I can find back what it should be. And what it is you have a double word, which is the total size of the hold file. So basically, if you have a file with the size, for example, 100, and the first 2 words have the indication 100, it's probably a hold file. There can always be exceptions, but that's the way it goes. Then you get first EA, next EA, next EA, next EA, and so on, until you eventually have encoded the last EA. For example, I've shown here the ASCII EA, this is only one, has 23 bytes, 17. If you convert that from hex to decimal, that's 23. You then get information about the data length, the name length, the data length, the name, which if you do 4D, that is DUMMY, dummy, just ASCII coding. Then the type of EA, this is an EAT ASCII EA, which has the code FDFF. Be careful, in OS2, the most significant byte is displayed last. It's just another, what do we call it, ordinal, Indian, and little Indian, yes. Yes, yes, yes. Yeah, the big Indians are Cherokees, right? Now, and then eventually you have the data. This is all encoded in that first data. So it converts everything. And that's the data in the hold file. Just you will have, of course, a lot more than that simple string there. EA Master will now display the contents of a hold file. It can also automatically identify hold files if you wish. This option is now in the Tools menu. As seen here, you just say hold file info. In the other options, you can say whether you want to see hold files automatically displayed. When you do that, you will see, for example, this is a hold file, and it is displayed in green. So we use color coding for file, directory, and a hold file. If you display a hold file, you can get a list of the contents of that hold file, which, for example, here is shown with the name, the type, whether it's critical or not, and the size. You have to be careful sometimes because the ASOC table is shown only as an EA size of 1 because that contains sub-EAs. So it only refers to the upper level. But you can very easily see what is contained in a hold file. As I said earlier, the ASOC EA, which is one of the main ones which has an MVM, a multi-value, multi-type EA, always has 4 sub-EAs, ASCII, ASCII, binary, and an icon. If you use the right-hand mouse button, you can also immediately get the contents of that particular EA in the hold file. And if you look here, FF, is multi-value, multi-type, one of them, and that contains, again, and so you can work through this, and you get the data both in ASCII and binary. That is about hold files. Next, I added the option to correct duplicate long names. When you're looking at a normal the directory view in details, you get, among other things, the title and real name. The long name is stored in the EA long name. And as I said, it may contain special characters like a slash, character return, commas, all the normal things you don't have normally in a file name. However, in your listing, in the directory list in details view, you do not know if the name under the title is in fact a long name, because if the long name EA is not present, it uses the real name. So how do you know unless you go and look, is there a long name attribute? As I said, when no long name attribute is present, it shows the real name. You think, so what? PM programs normally display the title, which is normally the text in the long name EA. It displays the long name. On your desktop, all the names are, in fact, long names. As I said, in the details view, icon, title, object class, real name and size, etc. you get. And as I also just said, the long name, if not present, is the real name. Now, all file systems, which we are used to, you cannot have a file with the same name. By definition, it would be crazy, right? Because which one are you going to get? Unfortunately, long names can sometimes be the same. This means that there is no logic in the operating system which will prohibit or give a warning on the fact that the long name is a duplicate name in the same directory. This can be a problem. I've run into this problem myself, thinking I'm opening file A, but it's in fact file B, and I keep changing it, and I, for example, recompile, and it hasn't done anything. I think, what am I doing wrong? I was opening the wrong file, but I didn't know it, because in the program, in the window, the long file name was shown. In order to check that you're not duplicating long file names, this has to be done programmatically in every program that does something with long names and file names. Unfortunately, there are very few programs that seem to do this. So you can generate duplicate names. How can you duplicate a long name? Come on, guys, you're all intelligent. It's very simple. Yes, okay. For example, you have a file called A, and it happens to have the long name test. So if you copy that file to an existing file that has a long name, an example, for example, what happens? You copy the file contents and you copy the EAs, among which is, of course, the long name file name. So when you can get, in this case, two files with the same long file name. So simple, it happens. And you don't generally realize it. I mean, how often you copy files and in fact you give it a new name. You don't think, oh, maybe the long file name also has to be changed. It's not generally a problem until you're in a program that only displays the long file names. For example, on the desktop, you can have two desktop objects with the same name. Which one's good? Okay, I ran into this problem, so I immediately decided I need to find a way to check this. And I did this by adding a long name checker into EA Master. And basically what it does, it reads all EAs in the directories you have specified. You can do it from the root if you like, and it will run through all EAs, the long file name, sorry, and see if there are duplicates in the same directory. Or it will use a bit of fuzzy logic to say the name is really strange in comparison to what you have had as the real name. And it will flag these. And you can then look at them and you can say, maybe I have to do something or not. So, any or all duplicate file names you can rename to the real name if you want. Here, this is a part. You may not be able to see this, but on the next sheet it's a little bit better. What you see is completely different names here, but they all have the same name here, the long file name. And if you're programming and looking at long file names, what often happens, you can screw yourself up nicely. So this program, if you select them, you can automatically say rename them to the real name. It has a backup in as much that if you change the long file name, it creates an extra EA with the old EA name, so you can always go back on any file to its original long name before you changed it. Belt and braces. Okay, we've done display the contents of a whole file, look at duplicate names. I then ran into a problem I have a file, and I have another file, and I can compare the files. The data in the files is the same. But is the data in the EAs the same? There was no way I could find it out. Maybe there is a program. I didn't find it, but you generally find it when you've made it yourself, you know. So I developed a utility which will compare EAs in 2 directories or 2 files. In this way, you can say, I have really identical data. I mean, you can have an MD5 checksum of the data in the file, but that tells you nothing about the EAs. With files, you have things like diff, fc, and so on, which compare the files, but nothing with EAs. So, we have now a compare utility in EA Master, which allows you, as I said, to compare 2 directories or 2 files or what have you, so you can see, is it really exactly the same? Obviously, in the directories, the files have to have the same name in order to compare. So in directory A, you have file C, and in directory B, you have file C. It will compare that the A's in both of those directories are the same. It will also check that there are the same EAs in both files. Not only are they equal, but are present. So if an EA is in one file, but not in the other file, it flags this as well. Or conversely, if there's an extra EA. This is what I just said. So what you get, this is the screen. I'm sorry, I couldn't make it any bigger, but I thought the screen was going to be bigger. But what you get is the file. It tells you if any EAs are missing from directory A or any files missing from directory B. It will then tell you where and what EA is different. So for example, what he says here is the MD5 checksum is missing in one file, and the data of the EA eno is different, and the difference occurs at the 4th byte. So you have an indication of where it may be. Oh, that's better. Now you can all read it. And when the compare's finished, it gives you a summary. Now, if like me, you can't remember what was on the screen when you just saw it, you have the ability to export the data so you can then look at it at your leisure later on to say, oh, that's exactly what was wrong. I would have liked to be able to do a demo, but unfortunately I haven't got VirtualBox on this machine. Otherwise we could have done a demo. But if anybody wants to see how it works, you're welcome after this presentation to come and have a look. Any questions? Or you're still all sleeping from last night? Still a problem with the tappers, eh? Yes? Not too difficult, Alex.
Yeah. That comparison feature.
Yeah.
Have you considered implementing something like a visual comparison, like graphical diff programs use?
I have thought of it. Well, the program you're talking about probably is GFC.
Yeah, or many
There
similar
are
programs.
others.
Yeah.
I have thought about it, but I think only if someone really wants it, basically. Do you really want it?
Hard to say at this point. I'm a person of limited mental capacity, so I have I operate better with visual.
Yeah, I understand.
indications, but we'll see.
Well, I had thought about it, but I thought I'll start with this, see the reactions, and if there is a real demand, then we can look into that. I don't know if I've used GFC often as not, but do you know there are certain characters which screw them up?
I'm not surprised. I know it has a number of limitations.
Quirks.
Yeah.
One of which is the arrow sign, the standard arrow right, standard arrow left, you know.
Yeah.
I use that in some of my source code. And when comparing, I thought, it's only compared halfway because he sees that as the end of the file, which is
Oh,
a
right.
bit
'Cause
frustrating.
it's a control byte, isn't it?
Yeah. That's
Yeah.
other questions? Who wants to pay for the graphical? No? Well, gentlemen, thank you for listening to me. And I hope you find this program useful. It is available via ArcNoah. The original version has been updated some time ago, so you can update if you bought it free of charge.
Okay, this is going to be one of the most unusual presentations that I've ever done, so bear with me. Here's a text that was written by the developer of UEFI. First of all, his nickname is Dixie, but he doesn't speak English very well. He does write English very good compared to other Russians that I know.
Not just Russians.
Secondly, thanks to Putin's madness filter, YouTube is now off the hook. You need a VPN. He can't access it. It varies from ISP to ISP. So we have an unusual bridge. Please save all of your, can you flip the page, please? Sorry, I should have flipped it.
Go on.
Can you turn the page?
Go on.
Okay. Well, yeah, that's what I want to say. His real name is Dmitry Zavolskov. I hope I pronounced that correctly. He is the developer of the QS init loader that everybody in the OS2 community has been seeing floating around. This is a open source OS2 loader, and he's also always had a small AV loader, which does nothing. You could just play Tetris on it, and that became the basis of what is today Arca OS. It's UEFI support. So please save all of your questions until the last moment. The only way that I could bridge him is that I've got an IRC session here on my laptop, and I can type questions to him in English, and I'll see if he responds. I'll put that on the screen for the audience, but we couldn't come up with no other way to bridge this. So, I think that covers it. Yeah, sadly it's blocked. We just checked, but he couldn't access the URL on his PC. So flip the page, please. So I'm talking on behalf of Dmitry, so I'll try and stick as much to his personal word line and choice so that you have a bit of an impression who he is. You know, so how did Dixie get rolled into OS2? I always find it interesting because we've never had any contact with Dixie apart via email, etc., or some forum posts. So as Steve sometimes says from California, and this is not meant derogatory in a negative form, OS2 users live in caves. And some of them are very skilled, and I think Dixie is a very exemplary pointing case. He started using it in the 90s when the FidoNet came up. For people too young, like one audience member here, FidoNet was the predecessor of the internet with bulletin boards glued together. Now, one of the things that made OS2 so nicely capable is that it could run multiple, it could connect easily serial ports on a PC, and you could run the FidoNet software. So it would actually be the predecessor that messages would go via FidoNet hubs. That's what made FidoNet so popular before the rise of the internet. So that's how he rolled into OS2, and he started using OS2 Warp 3 for debugging some DOS drivers and some other stuff, and that's how he rolled into OS2. There are, by the way, more people in the OS2 community I know that have a resemblance to FidoNet, because that's how they got started, setting up their bulletin board system with a stack of modems next to their PC. So what is QS init? Well, QS init is an OS2 loader, but it's a lot more complicated. The standard OS2 loader, and I'm adding some explanation to it myself, is just a 40 kilobyte bit of code, and that loads the kernel so that the rest of the OS can start. QS init is a completely different animal. It has a complete menu interface in it. It supports master boot record, GPT, FAT, HPFS, and you can also create a PA RAM disk with it. But for years in the QS init package, there was also this obscure AV file that kind of mimics what it did, and you could play Tetris with it. So now I'm going to get a bit to Dixie, what he's written. So it's going to be some, I'll try and, so what he says here, the history about the UEFI loader should start with the history of QS init. The history of QS init began in 2010. It was kind of an experiment to write not too much of a bootloader, but a boot environment with rich functionality. To some extent, it succeeded. The result can be called a small operating system, and those who tried its various features, I think, appreciate it. You, for example, see Sigurd Vastenrath in his YouTube videos using QSinit to quickly swap through to boot different versions of OS2. As I said, there's support for FAT, HBFS, and JFS. You can do partitioning with it, etc. After several years, it became logical to add an EFI version. The flat QSinit memory model is fully compatible with UEFI. So it means that in UEFI you've got 64-bit memory available, so it runs in protect mode, so it's quite easy to add components on top of that. So the point is, let's see here. Yes, can you flip the page, please? So what makes UEFI a challenge compared to the BIOS, and I'm intersecting some stuff myself, the BIOS provides much more services. So for example, when you switch on an old XT computer, it uses the BIOS to do the disk I/O. When you are in WordPerfect, it uses Int13 to read and write to the disk. The video memory is also, the video card is done by a special video BIOS. It talks to the video card. Everything is done. So basically, to put it really simple, MS-DOS was a wrapper around the BIOS. That's a bit cruel way of putting it, but there are whole lists of interrupts that you can use in DOS to do specific stuff. So what he gives here as an example is that the keyboard API in 1991 of a BIOS is richer in capabilities. In EFI, you just cannot distinguish between an asterisk or a star being pressed or the numpad from those pressed on the main keyboard. You cannot know the state of the Control, Alt, and Shift until the user presses some key, and so on. This just gives you an idea. What UEFI really is that it's still, in a way, a BIOS, but it has more become a Kickstarter to load the operating system. The BIOS, vast portions of the BIOS remain resident in memory. They are not unloaded. There actually used to be UEFI 32, but that never really came to fruition. The real cutoff date for UEFI was when UEFI really got introduced, is more or less tied to the release date of Windows 8. Because at that moment, if you want to have a Microsoft certified sticker on your laptop, that laptop was certified for Microsoft Windows, you had to have UEFI support. So UEFI has been in PCs for many years already, but it never was, Windows 7 kind of was semi-UEFI bootable, but not officially. You had to jump through hoops. And with Windows 8. So somewhere around 2013, the UEFI standard was pushed because Microsoft required it for Windows. So that's why I'm always saying circa around 2013, that's when UEFI got its push. For years you had machines with the CSM, but that's when the UEFI, around that time, the UEFI 32 standard was dumped out the window. It disappeared. Now, where is UEFI different compared to a BIOS? What UEFI does in the background is that it does some basic household cleaning, and what it really does is that there's a whole bunch of code loaded in memory, just like the BIOS, to talk to the disk controller. The problem is for OS2 is that at a certain moment in the UEFI spec, there is the call exit from boot services. This is where when the moment that code gets executed, all of the disk services, keyboard services, anything that the UEFI firmware provides, like making your mouse work in the graphical UEFI screen for the setup of your BIOS, it's gone. And from there on, the OS needs to stand on its own two legs. That is the big difference. Let's see here. So as he says, and the second problem is, as soon as you say that your OS has started, you lose all UEFI services. In generally everything console, keyboard, disks. The only thing that remain is the minimal services dedicated for updating the NVRAM settings, so storage, what device starts first, and rebooting and shutdown. That are the UEFIs. So it's only maybe 10% or less of the subset what the whole BIOS used to do after you had to call from exit from boot services. There is a rational explanation for discarding of these boot time functionalities. AV firmware takes a lot of memory space and it doesn't save resources memory allocation. It is highly fragmented and all of this can create difficulty for booting the operating system. So all operating systems, Windows, Linux, signal that an AV from boot services, the exit that I mentioned there, means that it can be discarded. This leaves us with bare metal. We have our own drivers and that's how we need to get it working. But this is the situation with any operating system under UEFI. The big challenge for OS2 is that it's a pretty modern operating system, but there are two primary things where it leans on. It's the disk I/O at startup, and it's the small, it's a tiny, tiny sliver of the video BIOS, maybe 10%. Most of the stuff is done by the OS, and that's what the UEFI loader that Dixie made. As he said, the only problem that arises for code that it is spoiled by the constant presence of BIOS services. The original OS2 dump from IBM fell victim to this. This is the simplest example. For people that don't know what OS2 dump is, in your root directory is a small hidden file called OS2 dump. And when you get a trap dump, you can set up the system to write all memory to the hard drive. That works via the BIOS. The problem is on the UEFI system, that's no longer there. So if you had the old OS2 boot, the OS2 dump, it could do a dump, and then in 13 is not there to answer the phone call, and then occupied, and that's the end of that. So that's why it works with AHCI disk controllers, but it talks natively, so it has its own code. Or you can do a dump to a memory partition, to a RAM drive. In case of the video, we need to either have full video driver, so that is Snap, or we are dependent on the UEFI GOP, which is basically only a memory address where data is being written to. So the whole bit with CGA, EGA, VGA, and VESA, all of that stuff is dumped out the window. It's gone. It's simply no longer there. So what happens is that during a boot of Arca OS, it looks into the ini file, what screen resolution it's set at, and if it cannot find it, it will try to query the screen via the EDID command. That's, for example, a small portion where there's a mini video BIOS that translates that call to the UEFI call, and it can then answer that this is the screen resolution we're running at. But that's maybe 5 or 10% of video code. Most of it runs without it, without using BIOS services. Sooner or later, we will definitively want to boot OS2 from it. What difficulties await us? First of all, we need to know, I said that already, the video. The other problem, and I'm sorry for the flimsy drawing here that I made, that's here. Well, the problem is that as the new PCs have been flooding the market, the CPU runs into so-called long mode, which means that it basically can have a memory address above the 4 gigabytes. The big problem is that the OS2 kernel is 32-bit. So that means that it can only address this section of memory, the 4 gigabytes. Now, a lot of devices have MMIO regions that are used to communicate with it and the video memory. A lot of devices have this above the 4 gigabyte memory. So when I was on the testers list, we already saw I think Alex Taylor was the first laptop that had that dreaded issue. It would start up. I think you were the first one. No. You were one of the first laptops that at least had this issue. And that issue is the following. The video memory is here. And what the UEFI loader does is that it loads in 64-bit protect mode. But since the OS2 kernel can only address 4 gigabytes, the CPU is switched back to basically call it compatibility mode, so that it can run. The problem is, all of these devices are on modern laptops live in this memory region. So when the OS tries to write to the memory address that is above this 4 gigabyte value, no answer. SETI can't call home. So what is in the loader is there's code in there, and this makes it truly, this is a real compatibility layer. It goes in, goes onto the PCI bus, and it starts flipping all of these devices over below this memory range. That also partly explains why some systems can't be made to work, because if you have a video card with, let's say, 3 gigs of RAM, it gets difficult to stuff that in there. There are more places in there, but most of the systems, it works. All of the devices are put into this memory range, and then the kernel can talk to the AHCI disk controller, can talk to the video memory. So that's the other big thing. Now, I'm just rereading where I left off. Actually, if the resize of, for example, the video memory fails, it will give a big red banner saying can't resize it. At least you know what's happening. If that's the case, you can only check if you can reduce the amount of video memory in the BIOS. And if you have 2 video cards, switch the video cards around, because some cards have a primary video card and the other one is secondary. And in some BIOSes, in UEFI settings, you can flip these 2 around. And then you might have a chance. If it then doesn't work, all I can say is consider it a technical marvel that we can run on UEFI in the way that it does. Consider this, the kernel hasn't been touched by IBM since basically 2002. Something Microsoft could maybe pick up something from, you know, I still think it's an achievement that it works. Let's see here. So the other thing that it does is that when you see the small ArcOS boot logo just before that moment, the UEFI loader still, before OS2 gets loaded, still has control. So then, after you have selected drive C, it jumps to the hard drive and it starts using the disk services to read the files from the hard drive and put them on a temporary RAM drive that will later be discarded. What then happens is that it goes through this remapping code, it does some other household stuff, and then eventually the CPU switches to real mode. And then it uses the OS2 boot file to start loading the files from the RAM disk. This is how every UEFI OS works. It caches, says hello to the boot services, and then it starts to load. There is some BIOS emulation. He says we need to prepare BIOS emulation, at least to the level expected for OS2 components, such as for video subsystem like Panorama or GenGrad, and especially for the DOS VDM sessions. At the same time, our BIOS emulation cannot be extremely complex. We cannot make a keyboard driver that would require a USB stack, a disk driver for SATA, AHCI. Our video is limited only to the mode that the user can select. So as we have to fit all of this into a few kilobytes of code, and the bigger it becomes, it will eat this off the amount of memory that you have inside of the VDM. Because deep underneath the bonnet, I understand that somehow the memory layout of how the memory is mapped on a physical system still influences how much memory you have inside of the DOS VDM. It's complex stuff. Fortunately, most critical BIOS components in the VDM are replaced by virtual services. So that means mostly the VDD drivers. Those are the virtual device drivers. So we don't need to emulate anything major except the video. And the kernel requires a certain things at startup. One of the things that's interesting is that, for example, the new True Color boot logo is actually done by the UEFI loader. It's not done.
Wait,
Yes, oh, sorry, pardon. Sorry, thank you. Sorry, can you actually flip back so that I can see if I missed anything? It's very difficult switching between this and that, sorry. Yes, I had that, thank you. Flip, thank you for reminding me, sorry. Yes, and we can instantly go to the next page. So now we get to the nitty-gritty stuff. Here you can actually see where the UEFI loader also has to do some homework. This here, this map here, I know it's very clunky, I'm sorry, and the lines don't add up. This is a memory bar of 4 gigabytes. So on an old system, every time, every PC that runs with the BIOS still sets up the CPU with the memory layout the way it was done with the first XT from IBM. 640 kilobytes of first memory, the dreaded 484 kilobyte memory region with the BIOS, and then the rest of the memory. The kernel still expects that. When the kernel is loaded, so when the UEFI loader has done its job, and you get to see the little boot blob says OS2 in the right-hand kernel, the kernel is woken up and says load. And then the kernel expects something like this. Now, you don't have to read all the details, but as you can see on the left-hand side, you can see all of the memory regions. And compared to a system with a normal BIOS, the memory is by far not as fragmented. There's a whole bunch of stuff that is related to UEFI boot code, UEFI firmware code. It's literally a moon crater landscape. Now, here's the problem. It needs to turn into the memory map that you see on the right, because it's expecting something that resembles this. So the UEFI firmware, the UEFI loader has to be smart as to how it builds up the memory. And eventually this, where it tells to the OS2 kernel, well, you can use this bit of memory on the UEFI system, and you cannot use that. That all has to be transferred to the kernel, and then the kernel can load. So that's another thing that the kernel does. Can you flip the page, please? So once the kernel then loads, all of the base steps are on the RAM disk. So your AHCI driver, the ACPI PSD, they're all on the RAM disk. And what that does, and this also includes, I think, even JFS, I'm not certain, but just around when it loaded all of the base dev drivers, then OS2 is basically able to replace the firmware, because then it has loaded the storage driver and all of the other stuff. But it goes further, of course, because stuff disappears. We used to have let's see here. Yeah, no, not here. So one of the other things that happens is that there is another portion of compatibility in here. As Dixie writes, after all of these base devs have been loaded, once this stage passes, the kernel is about to moving the regular drivers. If we boot from a GPT partition, then GPT FLT should have found our boot manager along with other mounted ones and create an emulated MBR disk for each of one. That's one sentence, but what happens is also a bit of magic. The problem is, how do you get OS2 to recognize a GPT disk layout? At the time, there were two approaches. Take everything out, that includes the OS2 LVM and OS2 DASD, and write something completely from scratch. But then also all of the disk tools had to be edited. It was a complete overhaul. So what came into place is something of a filter driver. And the filter driver is basically a software disk translator. It goes to the disk, it sees a GPT disk, and if it sees an ArcOS one, in memory, it puts a master boot record on it with a DLAT sector. And then later on in the boot process, it can actually use OS2 LVM and OS2 DASD to load the system. So for OS2, the boot partition just looks like a regular MBR disk. This bit of software that's in that filter driver does all the work. There's a performance hit. Turns out that it's actually, with today's hardware and NVMe sticks and SSDs, it's negligible. It's about 15% depending on what you do. So it's pretty smart. The size is also limited for each partition to max of 2 terabytes, but you know, we currently don't have hard drives of 48 terabytes, so we still have a long way to go. There is also a new OS2 boot. This is actually one of the files that is used by the kernel to load the files. That was also replaced. And can you have flipped, yes. No, sorry, you can go back one. Yes. One of the things that you might have seen in your OS2 configs and you never really cared about it is something called BVH SVH DLL, or this statement there, that line here. But that's the key file that is loaded very early on in the kernel, and this makes the kernel give text mode output, and it's able to load the PM shell so that you can get graphics. So we now have a new driver. BVH EFI DLL is a mandatory element. If it's missing, the system will try to load BVH VGA. Will break all output to the screen. Even if a VGA card still works, you will never see PM shell. BVH EFI DLL loads fonts from the system code page from VIO TBL DCP. Queries the loader for the format of the graphics card is running, creates a shadow buffer, and then you get full screen text output. So when you now see on a UEFI system your check disk messages, that's why we needed that DLL, because it talks to this frame buffer address. Now, one of the things that you can also see on an, yes, sorry, do you have a microphone for him? One moment, then the audience can hear it.
Does it need that even if it's running in compatibility, if it has a compatibility layer?
What you need to understand is it depends on how you boot the OS. It doesn't matter if a CSM is present, because when you boot it in UEFI mode, most cases the CSM code is not active. So you still need to use the BVH EFI. Unofficially, you can load it with a BVH SVGA DLL if a system also has a CSM. But there's little use to it. It doesn't yield much benefit. One of the reasons also that people like to use the UEFI boot is that now, for example, seamless WinOS2 sessions and DOS windows now work. It's guaranteed to work on any system. This was broken with the other. So there's little benefit to running running the old video handler. Yes? Okay. You can actually also see, after the drivers have hopefully loaded successfully, we get into the PM shell. Here, Panorama and GenGrad use the emulated Visa BIOS to get a list of the available graphics mode. If you also go to the screen object in the desktop, you'll see there that we are our own Visa BIOS manufacturer. It says Arkanoa LLC and Panorama Visa BIOS 1 or 2.0, something like that. As soon as the PM started, our problems mostly ended. WinOS2 runs via the PM driver, so this part is the least different from normal OS2 operations. Windows 3.1 games like Civilization 2 work without any changes. A completely separate part is the video driver for the VDM. This is done by vefi.sys. It handles CGA, EGA, VGA, and VESA emulation. All video output in the VDM is actually virtualized. Windowed mode was already virtualized in VSVGA, but full screen is virtualized here too. The VEFI code is based on extremely reduced version of VSVGA.sys. All hardware access to the chipset support has been removed, but WinOS2 and window mode logic remain the same, as we can't change anything in PM, so it's best not to touch that works. From a user perspective, Windows mode works much better because the video in VGA mode is now fully virtualized, not partially. Messages about the mode is not being supported in a window can only be seen if you have an old VGA card. But here we come to another point. Neither the VDM nor VSVGA have ever fully emulated the VGA BIOS code. In fact, VSVGA only has code that replaces the scrolling in text mode. Everything else is done by the video BIOS. Yes, please flip, sorry. Oh, I made a typo there. That's what happens when you work at 15 minutes past midnight and you turn into a pumpkin. UEFI has a VGA BIOS. The UEFI system has no VGA BIOS. So, yes, I've got it there. So, the whole video card is emulated, and the problem is that does have an impact. Over the years, you don't want to know how many different ways you could access a video card for that DOS game to work quicker. This is only, this is actually a VGA BIOS. If you call it on real hardware, it will work correctly, set any standard CGA, EJ, VGA mode. Although to save space, some rarely used functions have moved to VFI.sys. In the VDM, this video works with the CGA, EJ, VGA emulation. This is somewhat comparable to what a virtual machine does. The big difference is we only virtualize the video. The rest is running on bare metal, which gives us a performance difference that's actually better. Yes, can you flip the page, please? So, what he said, there are some programs that can still generate a pop-up message that's specific to this one.
Robert, can you slide your white screen
To the left.
Yes, thank you.
You're welcome. So, for now there's a whole bunch of stuff that I don't think I really want. Well, actually, I can do that. I'll do that later. The VGA portion is extremely complicated. There's a whole bunch of different modes of how the video memory can be accessed. I think one of them is VGA planar mode, where the difference is that how the game talks to the video hardware, it does very frequent access of the video memory. The difference is this now has to be emulated in software, which is slower, period. So some video modes work quicker than the other ones. If you go back to Warpstock from last year, Matt Narauki did a whole comparison between running games on Arca OS, and well, there you can see the difference in frame rates in games like Quake, for example. If you actually get one of these, this is the VGA planar mode. Each video memory access raises an exception where this instruction is parsed and executed in software. Some rare CPU instructions are still not emulated, in which case you will get a one-time pop-up which will appear like this. Save its content, the name and version of the program that caused it, and then open a ticket with ArcNoa. I hope you are not falling asleep yet, but kind of get to understand what complicated stuff this is, where basically a complete video card has been re-implemented in the DOS support. And this is only for DOS, by the way. This is only for the DOS stuff. So I would like to refer you to the presentation from Matt Narauki that you can find on the website or on YouTube. There it goes into the performance of all of these different video modes. Can you flip to the next page, please? Oh, yeah, sorry for the bad text. The blue text there says, please go to mondesarcanoa.com. So if you ever encounter that message that you just saw, open a ticket and tell us what program it was, and then with the register info. So if you just look at it overall, and that's also what Dixie writes here, is that VESA support in VFI.sys is completely independent of the VESA emulation at boot time. It has its own list of modes and is mostly compatible with regular VESA BIOS. The BIOS shows a default set of resolution plus the native UEFI resolutions with 8, 15, 16 and 32-bit modes. The VESA API is supported on a level expected from a typical DOS video card, which is well enough for game. The latest bug that we found was with Blue Quake that was presented in 2023. This was an error in one of the VESA API references, so use it without worry. Okay. There are also more text modes in there, so if you want to run, for example, an old accounting program or Warpstock, these text modes are also supported. To give you an idea here, there's support for the text mode 132 times 25, 132 times 33, 132 times 50, and 132 times 60. Don't tell us it wasn't tested. I've spent ages with Dixie going through DOS games on the testers list and going one by one through them. And so for example, Battle Chess wouldn't start. It required a special call in the VESA BIOS to be implemented just for that game. 20, 30 other games would work. This is just WordPerfect 6.0 can even start up in VESA mode with 1280 in graphics mode. That all works. So, but this all shows. But he says here is that as for the rest of the BIOS functions, they are supported very poorly. But there's no reason to do it differently. Emulating of disk I/O at boot stage would add the need to have yet another driver, etc. This is extremely irrational, and there is no direct access to the disks from the DOS VDM anyway. Keyboard services are used only in the VDM and are completely replaced, for example, by vkbd.sys. Other rarely used BIOS interrupts like int13h serial I/O returns at least the correct error code. Anyway, nobody used the BIOS even in the DOS times. Some BIOS tables still need to be emulated to avoid some side effects, but such as broken virtual floppy support in VDSK.sys. The number of non-obvious dependencies is very large. With a lot of testing, we created something that works and is useful. I hope you enjoy the results. Dixie. Sorry for reading it like this. I wanted to get him online personally, so this is somewhat of his words. Can you flip the page, please? Mm-hmm. Have I stuck a bit in? Okay, I will now, are there any questions? I have Dixie here on the IRC chat. I wish it was different, but so are there any questions? Oh, yeah, thank you. Are there any questions?
We're all dumbfounded.
Oh.
Awestruck is a better word.
Sorry?
Awestruck is a better word.
Yeah.
Sorry?
Awestruck.
Okay.
The only question I have was already answered, and I didn't understand the explanation. It's probably best if I don't ask it.
Can you switch to my laptop again?
One moment.
I think I should just take the courtesy to say thank you to Dixie and that he knows that. Now I hope it's going to switch back. Yes. Oh, now the clock does display correctly. I hate that when it happens. Oh.
Mr. 40.
Oh, where? Oh, here's it. Hello, Dixie. we are sorry you cannot follow the stream. There are no questions here. Thank you for helping with the presentation. A bit of a unique way, and on behalf of all OS2 users, I can say thank you for your big work on OS2. Oh yeah, sorry, I'm typing with a flaky keyboard. So I tried to get some more people out of the woodwork that have never spoken. I wish that he could have spoken himself, but also his English. I've tried to convince him over the years, but he's very shy. Oh.
Yes, I want to later.
Yeah.
Yes.
Get a VPN. Nah, he's trying.
Yeah.
So.
Send him the file.
Yeah, that can also.
Send him a recording.
Well, there you have it. At least I've got a. This afternoon there will be another unique presentation. Richard Durand, he's somebody that used to work for IBM. He later worked at ESS, where actually wrote the PCI drivers and the ISA drivers for OS2. And he'll give a presentation later today and he'll tell you what he's worked on at IBM. He's now retired since a year and he's enjoying life, but he still has I got this t-shirt from him, as you can see. OS2, been there, done that, and it says OS2 Warp Chicago. So,
was Dixie also the guy who created OS2 boot from USB? Or
no.
stuff also came from the Russian head?
No, that wasn't something that Dixie made. No.
Okay, yeah.
So, just to give you an idea, this is the first author that worked on such low-level stuff, replacing OS2 boot, BVH EFI for the video handler. VEFI.sys has had about 50% of its code rewritten. You can see it yourself, by the way. If you go into the DDK, you can look up the sources of VSVGA. It's about 130 kilobytes of pure assembly code. Go read it on a rainy afternoon. You'll probably fall asleep. That all has been patched out and is now working this. As far as I can tell, there have been little. You have a question, Louis?
Well, I just wanted to clarify something because you weren't particularly clear when you were discussing UEFI 32 going away versus UEFI. UEFI is 64-bit. So if anyone's wondering, well, if UEFI 32 went away and OS2 is a 32-bit operating system, how does that work? Well, the UEFI loader is actually a 64-bit loader, which loads Arca OS in 32 bits underneath, after it. I shouldn't say underneath it, but after it. But UEFI is 64-bit.
They had a UEFI 32-bit loader support, and that went away. That's what I should have said. Yeah.
Right.
That was short-lived. There were a few murky machines that had it. So.
I think that was 32-bit Atom CPUs or something like that from Intel, which were not.
Microphone, please.
Microphone.
Okay.
If I remember correctly, there were some Intel Atoms or so which were 32-bit, but stuff sold with them, and so the system manufacturer had a UEFI in 32-bit mode to provide.
The CPU never had 64-bit extensions. That was probably it. Maybe that was it. Yeah. Okay.
But as all CPUs nowadays are 64 bits, there was no longer a need for a 32-bit UEFI system, and
Dixie
that's
writes,
the reason because it's gone.
Dixie writes, this task was really interesting and it was a bit revolutionary, but it all worked out. Are there any other questions before we have a pause and have lunch? Are there questions for Dixie before I tell him thank you for joining?
Just thank him all.
Yeah. Oh.
One question.
We talked before about using our only remaining real video driver that addresses hardware directly And you said something about that also having implications for UEFI. It would be pretty difficult to implement.
From what I understood from Dixie, the caveat is that when the UEFI loader starts up, and well, you know, he's here, I can ask him, Dixie. Can Snap be fully made to work with native chipset drivers under UEFI boot, since we set the screen resolution of the UEFI video buffer and effectively freeze it. I think you also stated that the VEFI.sys support might be impacted. Can you please comment? It feels like sitting on a telegraph to somewhere very far away. End of telegram, waiting for reception.
Didn't we have voice type one time?
Well, maybe you should go to like stop or over.
That's what I recall. I seem to recall that the current Snap version works because it's a Visa driver. So what that means is that it works basically the same as Panorama. The difference becomes that Snap then sets its own resolution. I don't know how that works with the frame buffer code. It might just work, but
It can, but only Vesa.
it can, but only in Vesa mode.
Which means
We will need
snap.efi. So that module could be loaded during UEFI boot phase and program or talk more to the GOP portion and provide with us with some more resolutions.
There is also more overarching thing. I think if you look at Snap and if you look at the performance on today's even high resolution screens, there are two key reasons to have Snap. First of all, if you'd like to have an external video port to work, and the other one is if you want to have, if you want to use multiple screens. From a performance vantage point, I think David once at Warpstock told me, Snap is great, but it's such a bulky piece of overhead. There's so much code, and Panorama is a single DLL. The reason that at the time Snap worked better than the standard grad driver in EFI, AFI mode is definitively broke the video. Wait, what do you mean? Sorry, I was just, sorry, what was I saying? I got, my context hook was driven away, sorry.
You were talking about the speed of
Yeah.
Snap.
The thing is, what people, there has been a subconscious thought with everybody that Snap is quicker. But that was partly because the grad driver from IBM didn't set up the so-called MTRR registers correctly, which made a PC feel like an old XT. But ever since David Azorera has fixed up the MTRR register setup and the support for PAT, in practice, because the video subsystem of OS2 is so lightweight, you don't notice the difference. Even when you look at dive benchmarks for video playback, so if you use something like MPlayer, it's actually pretty good. So the point is also for Snap, somebody needs to write the code per chipset. When I was still working on Ecom Station, I know that at a certain moment, a specific video chipset was working, and then another family from that chipset didn't work. So there's also a cost to developing it. And then the chipset has to be certified, has to be tested. We see the same things when I look in the Arc Noah bug tracker sometimes, that suddenly a specific Realtek chip, I'll just take an example, there are 80% of them work, and then there's one chip that doesn't. The benefit of this panorama approach is that it works on just about any machine. And here's the real thing, most laptops have, Snap will just trap the system in AV mode, especially without VISA BIOS.
Okay, that's broken.
Then you
Yes.
ask him my question about snap.efi
variant. Type it to Dixie that he could see the suggestion about snap.efi.
You know why it's not going to work? Because then it would probably need to have chipset-specific commands in there for it to work. This is again the problem that we have. If you looked at the support for video on OS2, there was always the dependency on the BIOS. There was an access towards the VESA BIOS that it could do all sorts of stuff. There are either now two flavors. Either you fully support the complete chipset, or you use the UEFI GOP frame address. And what I also understood from him is that the DOS support will also be impacted by this, because it has its own VESA BIOS. It's all woven into each other. And we have a few kilobytes of code to stick it in. And the question really is cost versus benefit. Lewis needs to answer that question. But I think technically, when I looked at Menzies at some of this stuff, you just see how narrow our path is to get something to work. So even if you write a BVH snap DLL, it needs to talk to the hardware in the correct way. And the only thing that the BVH EFI DLL is it talks to the memory address. That's what makes this setup supportable. Yes, Alex.
Just kind of a random thought I had when you were saying that. I get that it's not feasible to support chipset-specific features in any sort of general way through that. Would it maybe be possible to identify a couple of specific things that pretty well all chipsets support, maybe via slightly different channels, and maybe just one thing, external HDMI port, for example, and create like a translation layer for certain chipsets for that?
I can answer that question. I've talked about it with Dixie because I was interested in it as well. This laptop and Lewis's laptop were both lucky bastards, you know, it works. But other people are out of luck. What I think might be possible, is that somewhere in the UEFI, can you do that? It might be possible that you somewhere stick in chipset-specific code. There is nothing that can prevent you to talk to the video chipset itself and poke a register somewhere to say flip the screen. Here's the problem. You see it going wrong here. But what the UEFI code does is that when it loads, it talks to this is why this laptop has to reboot. The cable is connected to the beamer, and it talks to the beamer and says, "What's your resolution, bro?" The beamer says back, "I have that resolution." Now here's the problem. If I have a high-res screen at 1920 times something 1280, that resolution is frozen. It's stuck. It's locked. So that means that when you then attach a beamer on your HDMI port and it only supports 1280, and you could even flip the register, you can't change the size of the resolution because it's stuck. That is a bit of a, so that might be fixable, that you switch the resolution manually and that you then reboot and that you then flip the resolution, that you then flip the port over. That might work. And you could maybe do that even with a DLL or a small device driver to poke. The problem is somebody needs to go into FreeBSD or Linux code and figure out where the bit of code is that when you press the key combination on your laptop, that it sends down to the chip, switch to the external port. The other problem is, what port do you want it to switch to? Because this one has an HDMI port, but then the fun starts, because there are some laptops that have a VGA and a display port on it. So it quickly starts to run out of track. About 5 years ago, I looked with Rich to see if we could do something on my laptops to get the screen to get the brightness of the backlight lowered, because there are two energy consumers in a laptop these days. That's the CPU fan. Nothing can be optimized on that for Arca OS. It's already switching off cores so that the CPU fan doesn't run that fast. But the other battery saver is, if you're running on battery mode, could you dim the backlight? It turned out that that was kind of the same nightmare as well. Some displays have got an option that you can supposedly via ACPI lower the screen brightness. I've got a couple of executables on this laptop floating around called dim 9810 to try different methods. That also didn't work. You also needed to talk to the chipset. So you kind of get the gist. It's difficult to come up with something that would probably work user-friendly. I would also like to have that. I've gone down the rabbit hole, and it was a dark alley.
This came up, I think it was yesterday at dinner, but I have a machine with Snap, and it will boot into both. It will boot in UEFI mode and will boot in compatibility mode.
Oh, yeah, he also writes, that's what I said, both VEFI.sys and BVHA will be affected if Snap would be supported. So it's not just an isolated change if you want to support Snap natively.
Which video card do you have in there? Is it a supported Snap chip?
Yes, it's an ATI 600, I think.
It's an ATI 600?
Yes, so I'm running dual monitors. When it boots in EFI mode, there's a period of time, 10 to 20 seconds, where the screen just does these weird triangles. But then once PM shell loads, it comes up and runs. I think there's a problem with either DOS sessions or Windows sessions. I don't exactly remember. But it may be because the installation is for CSM instead of UEFI, and so don't you have a UEFI
There's a
driver?
partial BIOS in the CSM, which is, that's one of the things that, when you have machines that behave funny with video, the first thing to suggest is turn off the CSM.
Yeah. Well, this one actually works better with the CSM than it does
Some will, some will.
without the CSM.
Also, one thing that we noticed is that in some cases, I have one laptop at home where actually switching off the CSM gives you 200 megabyte extra memory under UEFI boot. So sometimes it's interesting to test that.
Yeah.
So implementing Snap on UEFI, it's probably possible. The question is how far can break it. Now, there is an unofficial back path that you can take, but there is probably there's as we say warranty in Dutch to the doorstep that it works. There is a undocumented way that you can load if your system has a VGA card that you can load in UEFI boot, that you can load with the classic DOS support. But I would strongly recommend not doing that. It's not tested, so.
Well, I probably should add, you can't install it with the ATI. I had to put another card in because the ATI card isn't recognized by the BIOS in UEFI mode to start up. So I had to buy another card that was recognized, start it up, get it loaded, installed, and load
allow onboard video in that system?
I talked to David about it. I think the issue is how it's reporting screen sizes. I think it's something like that, but
Also take into account that when you switch on a system to boot in UEFI mode, from the moment that even if you have a CSM, depending on how the firmware is implemented, it could actually result that just the VGA functionality is switched off. Because once you do that, the system expects that the BIOS also starts using the UEFI protocol, because your screen output at that moment will have to be outputted via that format. And then it expects a UEFI loader to be loaded. It doesn't expect a lot of the code path is simply completely different. But that all depends, that's up to the generosity or the way that the developer thought that it had to be implemented. So what a lot of BIOSes do is that they also check if a video card supports UEFI GOP, because the firmware and the video card have to work together so that the operating system can make that work. So
well,
that
my conclusion on that is UEFI machines are substantially more complex than
yes,
previous machines.
they are.
It's actually amazing that it works at all, but it's, I mean, building the machine is a lot more complex now than it used to be.
The reason that they also moved UEFI is simply a trend. At around Windows NT4, you had the height of the BIOS madness, to put it like that. So even the BIOS was involved with the suspend resume process. You can talk to Richard Durant, who will be presenting later today. I can tell you that it wasn't very nice to have the suspend resume process work between the BIOS and the operating system. And what we've seen over the last 20 years or so, and this is a gradual path, is that you've got ACPI, you've got UEFI. And the whole idea behind it is to simplify the OS, to simplify the mainboard architecture and load more stuff onto the operating system. I know that's a very brute summary, but that's what it effectively boils down to. The other thing that's cheaper about UEFI mainboards, they write the code in C++. You no longer need assembly monks to write the code, because now, so this is also, when you go into the UEFI loader, there's a memory map option under diagnostics. You just go through that list and see how many megabytes are being loaded for UEFI code. On the other hand, this is one of the ways that Mac also downloads, I think, Mac OS, because inside of the UEFI firmware, there's also a complete IPv4 and IPv6 stack. So you can actually stick in and use the UEFI stack to start downloading an operating system or boot it. So it provides a lot more support. It's yin and yang. Are there any other questions? Yes.
I do
Wait, microphone.
I do know in EFI that not all systems have the IP4 stack, because you can execute in the EFI mode certain commands and check this out, and some of the things don't work, meaning it's not there in that particular EFI.
Also, as a warning, and that's what I've also understood from code, let's just say that the UEFI code on some machines is of the UEFI firmware is of a mediocre quality. That laptop that you see over there, I tested ArcOS on it. About a year ago, it wouldn't work. When you would, well, it would boot from the stick, everything works Ethernet. But the moment that you would reboot and all CPU cores would be switched on, the system would magically reboot and it was dead as a doornail. I asked David to look at it, was nothing that he could fix it. Guess what?
EFI update.
10 months later, a new firmware update apparently got installed when he was on the Windows, and I put in a stick and I reinstalled. Hey, it's working. So the gist of it, just like with all hardware, the benefit of UEFI is that the marketing department can push a product out quicker out the door. So if you have a problem with the UEFI boot, always keep your firmware up to date. That's the gist of it.
That's what I was gonna say. That whole issue with the IPv4, IPv6 seems to be driven by the market.
Yeah.
And there are some manufacturers where it disappeared and 6 months later it's back.
So, are there any other questions?
Yeah, actually. You said something about when you're remapping stuff to fit under 4 gigabytes, you said that the size of the video RAM can be an issue.
Yes.
And you also said that if there's an option to reduce the size of the video RAM in the UEFI BIOS, that can help.
Yes, if you can get it small enough.
Is there any reason why the UEFI loader couldn't have an option to cap off the amount of video RAM it moves and makes available?
You raised the same question as was raised by Marcus Montokovsky, the other OS2 developer that did the USB res manager. When we had the first laptops with BIOS problem, remember, where they only had 512 megabytes of RAM, the question was raised like, can you not chop it off? And he was actually saying, why not? So you make a very valid point. The problem is probably somebody needs to try if it works. So the question is this, and this is where it becomes brute. OS2 has a maximum amount of video RAM that it can use. So the question is, if you have a laptop that has a 3 gigabyte memory buffer and it's mapped into system memory, why can't you just remap it below the 4 gigabyte boundary and set it to 128 megabytes of RAM? I don't know if you need to start poking around in the PCI config space to do that. This is uncharted waters, but your thought has resonated with other people as well. So yes, it might be something to look into, because what I was saying to Lewis yesterday, there's a probability we'll see more laptops with just more video RAM. Just like with the screen resolutions, it's an assumption that it will probably not get smaller, the resolution will just be cranked up further, which is just...
I think my laptop has 8 gigs of video RAM, and that's pretty modest by today's standards.
Yes, and I know that your laptop also has, oh goodness me, what is it called? There's a special option to reduce the size of the, there's a special...
Yes. I need to move my machine.
There is code in the UEFI loader that goes in and it tries to change a size of a buffer address of a buffer that is used, and that has made some systems work. And on other systems, you can use that buffer to increase the size to increase the video performance. So Dixie implemented the other way around to reduce it. That's also, I think, your laptop has. How much gigs under OS2?
I think I've got around 3 gigs.
Yeah, which is very good.
Yeah.
You had a question?
Well,
Otherwise,
maybe I'm missing something, but if you start messing with the amount of video RAM, isn't that going to be a chipset specific event? I mean, you can limit it in the...
No, the idea is much simpler. Is that, well, here, actually thinking about it, here's the problem, Alex. How do you convince the video chip to remap 3 gigs of RAM below the 4 gigabyte memory line and then suddenly chop off 2.5 gigs of video memory? Will the hardware accept that? I don't know. Somebody simply has to test that. Greg has a question.
Why not just put the base address of the video just below the 4 gigabyte level, leaving just as much RAM below as you need, and the rest of the RAM is still there, but it's above the 4 gigabytes.
Lewis, did you hear that one?
I didn't, I was trying to find
No.
that setting.
The concern I
Sorry.
would have with that is if the video card is then trying to do stuff that we need, but it's writing it above that barrier. I don't know much about
Well, here's the real joke. The only thing that we need is that we need, basically the way I see it is that UEFI GOP is almost like a modern telex. It's just a memory address, and you write to that address, and that fills up the screen buffer. That's it. So what Greg came up with as a solution What happens if you just take the 3 gigabytes of memory, you lower it partly on the boundary below the 4 gigabyte region so that you have at the top 265 megabytes sticking out below there, and then you can write to that, because then the starting address is there. And since OS2 can only do 64 or 128, it will never go above that. I like the idea. It's worth investigating.
It's an interesting thought. I need to run it past David to see what he thinks about its
I have no idea.
No, but
whether it would work, but it's just.
It might be that the kernel itself loads itself directly below the 4 gigabyte mark, and no?
No.
Is that flexible?
No, it's not. This is one of the problems that Dixie ran into. One of the reasons that also the boot services have to be dumped, that memory, is that the OS2 kernel expects to be loaded in the first 16 megabytes of the PC. If it's not there, end of boot. So that's why those boot services that are sometimes at the beginning of the system memory have to be unloaded before the kernel can load. So you can't stick the kernel at the top of the 4 gigabyte boundary. It has to be physically in the first 16 megabytes of PC memory.
Probably because of the 16-bit origin.
Probably.
But that's a high memory kernel space, and
Yes.
that's below the 4 gigabytes.
That's for kernel memory allocation.
Okay.
But if you rewind, this goes back to how old the kernel is. If you look in the config sys, there's also a statement called early meminit equals true. This also shows you the echoes of how old the kernel is. Because if you take that option out, the kernel can only allocate up to 16 megabytes of RAM. You can illustrate that on a modern system by taking it out. When you then start up your system, somewhere around UniAuth or FAT32, you'll probably crash out with a kernel trap because it doesn't have enough memory. The point being, it's the same 16 megabytes boundary. That's why that early meminit equals true is in there. We were glad that Scott Garfunkel from IBM implemented that little jewel just before he left OS2. Because without it, we wouldn't have been able to load all of these big drivers like ACPI and UniAuth.
Just don't try to use HP Fast 6.
No, that blows up.
That BIOS setting was Intel SGX.
Oh.
Software guard extensions. When you turn that off, you recover a little bit more VDM space.
Okay.
With it on, you lose, I think, the upper 64K of the DOS VDM.
Well, that's not what I meant. There's another thing. I'll look it up later. I'd like to suggest that it's now 11:45. I think it's time for lunch. I hope you like this kind of adventurous travel through the well, it's recent history, so this is just it. I've always said about keeping my OS2 alive to boldly go where no fools have gotten before, to take the start. I mean, you must admit, it is mind-blowing. And thanks, Greg. I like that idea. I really like it. I never came up with this silly idea, so maybe it has a fighting chance to work.
Yeah. This sounds a bit like great minds think alike.
One of the things that I was discussing with Dixie, which I called PA video, but it's so ugly, it's so dirty. The idea is actually that you put a video buffer below the 4 gigabytes, a frame buffer, and then with a kind of remote desktop protocol, copy the data and switch the PAE memory back and forth and then dump the data in the real video buffer. But that has a performance hit, and you probably won't be happy about it. I talked to Steve about it, and he said it might be doable. But Greg's idea sounds much more interesting, because then if that indeed... Can you send an email to David? I'm dying to know what he thinks about it.
I'll do that. I'll ask.
Or we can ask Dixie what he thinks about it.
Yeah, he's on the
Yeah, I'll send him an email later. Thank you for your time. There is now lunch.
If he's going to